Welcome to the deep dive. So, you sent us this really interesting Python script, and that's what we're going to do today, really dive in.
Yeah.
Our mission, as always, is to pull out the most important, the most useful bits, giving you a kind of shortcut to understanding what this thing can do, for your own coding projects. This one's for you.
And it's a meaty one. This isn't just some small utility script. It looks like it's built for generating code, modifying code,
Right.
interacting with AI models, both local ones and online ones.
Yeah.
We need to unpack how it actually does all that.
Exactly. We got the full source code pasted in, so it's a lot to look at. Tons of imports, functions, classes. Where do we even start with something this big?
Well, the beginning is usually a good bet,
Yeah.
right? Those first few lines can give you clues. Like there's this commented outline. Hashtag requires pip install PAV.
PAAV. Multimedia stuff.
Yeah, usually. Now, it doesn't seem to be used later in the code snippets we have, but its presence suggests maybe they were thinking about multimedia processing, or maybe it's planned for the future. It hints at a bigger picture.
That's interesting. Yeah, like a little archaeological clue, even if it's not active. Okay, then we hit this long list of imports. Quite a mix. Anything stand out?
Oh, definitely. The imports map out the capabilities. You see Tinkinter right away.
Ah, so it's got a GUI, a user interface.
Exactly. Not just a command line tool. Then you've got iter tools, read for regular expressions. Those are workhorses for manipulating text and data in like sophisticated ways.
Okay, so text processing makes sense for code.
Right. And then request pops up.
Okay, so it talks to the web, APIs probably.
Definitely. And then newer additions, it seems.
Yeah.
P-audio and sound file.
Audio, what are those for?
Well, P-audio lets the script grab audio input, like from a microphone, and also play audio out. Sound file handles reading and writing audio files.
So recording, or maybe voice commands, or reading out results.
Potentially, yeah. It strongly suggests audio features. And like you said, we do see a commented out transcribe audio function later using something called faster whisper. So speech to text was definitely on the mind, even if it's not, fully wired up in this version.
Gotcha. So the groundwork's there for voice stuff. Okay. Moving down, there's a speak text function. That seems pretty clear.
Yeah, that one's straightforward. It uses PyWin32, that's a Windows library, to tap into the built-in Windows SAPI voices.
Text-to-speech, then.
Exactly.
Yeah.
Allows the script to talk back to you using your system's voices. And importantly, it's got error handling. If the speech thing fails, it won't just, crash the whole application.
Good planning. Okay, so we've got UI, web stuff, potential audio, text-to-speech. Now, this configuration and globals section, this looks like the control panel. What's important here?
Yeah, this is kind of the nerve center. These global variables define how it runs. You see current stream resp, current resp, and stop streaming.
Streaming. Sounds like asynchronous stuff.
That's the strong suggestion, yeah.
Yeah.
Especially dealing with AI models, responses can take time or come back in chunks, and that stop streaming variable, that's key.
Ah, the ability to interrupt it.
Exactly. You hit a button, it sets that flag, and hopefully the AI process stops. Super important for usability.
Definitely. Okay, then local models and open router models. Now we're getting to the AI part.
Right. These lists define which AI models the script knows about. The local models, like Quyk or DeepSeek examples, these are models you might run on your own machine, maybe using something like LM Studio.
Okay, offline AI.
Yep. And then open router models like that DeepSeek R1 distill-llama 7db, that free entry that points to using the open router platform.
Which is like an aggregator for different cloud AI models.
Exactly. Gives you access to a much wider range, potentially more powerful models hosted online. So you get a choice, run it locally or use the cloud.
Flexibility. Nice. We also see options file path and models file path. What about those?
Those are for saving stuff between sessions. Options file path probably holds your settings, like which model you prefer, maybe API keys. Models file path likely keeps the list of known models, makes it persistent.
So it remembers your setup. Convenient.
Okay, then LM Studio API and local REST API, connecting to local AI servers.
That's exactly it. LM Studio API is the default address for LM Studio, which is a popular tool for running models locally.
Right.
Many of these local servers use a REST API, basically a standard way for programs to talk over a network. Local REST API suggests it can connect to other local REST endpoints too, not just LM Studio.
So if you're running models locally, this script can talk to them.
Got it.
And look at this system prompt. It's really detailed.
Oh yeah, the system prompt is fundamental. It's the initial instruction you give the AI, telling it what its job is, how it should behave, how to format its output.
And this one's very specific about code.
Very. It says, you are a coding assistant. Provide complete runnable scripts And crucially, enclose the entire updated code in triple backticks, and do not include language labels. Ah, so it's trying to get clean, predictable code output.
Exactly. That kind of prompt engineering is vital to make the AI's output immediately usable by the rest of the script.
Makes sense. Then max tokens is set pretty high, 8192. Why such a big number?
Well, language models process text in chunks called tokens. Max tokens limits the total length of the input prompt plus the generated output. Setting it high, like 8192, means the script can handle larger chunks of code as input and receive longer, more detailed responses from the AI without cutting them off.
Important if you're working with big files or asking complex questions. Okay, then a block of open router variables, setting up that connection.
Yep. Default TC Open Router is just a switch use Open Router by default, yes or no. Then you need your Open Router API key, that's your personal credential.
Right.
And the model name to use on Open Router, the site URL, site name.
Yeah.
All the config needed to talk to their service.
So plug in your key and you can tap into all those models. Cool. Last one in this section, max history logs. Sounds like history.
Pretty much. It limits how many past interactions your prompts and the AI's answers the script keeps track of. Lets you look back at what you did before.
Useful for tracking progress or remembering an old idea. Okay, that covers the config. Now we see functions for loading and saving options and models. This persistence seems key.
It really is. Load models, save models, initialize models, load SIR options, save SIR options. These handle writing your settings and the model list to disk and reading them back in.
So it remembers you.
Yeah, it makes it feel like your tool, not something you have to set up from scratch every time. Much better workflow.
Definitely. Okay, next up, QLF search functionality. Built-in search.
Looks like it. Perform search and open search pop-up. Standard find feature, probably for the code or response text areas. It mentions a reverse option too.
Nice, like a regular text editor. Cedo L plus F is muscle memory for most people.
Exactly. Makes it intuitive.
Okay, now whisper recording constants and functions. This loops back to those PyAudio imports.
Right. The constants here, format, channels, rate, chunk. These are standard audio settings.
Okay.
Sample rate, bit depth, monostereo buffer size.
Okay.
And then silence threshold and silence agitation. These are clever.
How so?
They're likely used for automatic speech detection. The record audio function probably listens continuously until it detects silence below that threshold for longer than that duration.
Ah, so it automatically stops recording when you finish speaking?
That's the idea. Then it saves the captured audio to a WAV file. And again, that commented out transcribe audio function using faster whisper hints that the next step was meant to be turning that WGV file into text.
So the recording part seems functional, transcription maybe not yet. Still, the potential for voice input is clear. Next, custom dialogue MSG box replacement, creating its own pop-ups.
Yeah, instead of using the basic Windows message boxes, it looks like they built their own using the custom dialog class and custom dialog function.
Why do that?
Control, mostly. You can style them however you want. It mentions a dark theme, so it probably matches the rest of the UI. And you can create different types. Info boxes, yes/no questions, boxes to type text into, more flexibility.
Right, keeps the look and feel consistent. And related to UI helpfulness, the tooltip utility.
Simple but effective. The tooltip class and create tooltip function just add those little hype bubbles that pop up when you hover over a button or something.
Explains what things do without cluttering the interface. Good touch.
Very standard usability feature.
Okay, now we're really getting into the core AI stuff. AI response, parsing, and code. This is where it deciphers what the AI sends back.
Super important step. First, extract code block. It uses regular expressions, regex, to find code fenced off by triple backticks.code.
Standard markdown format for code blocks?
Right. Then clean code snippet tries to strip out language labels like Python or JavaScript that sometimes sneak in right after the backticks.
Even though the system prompt told the AI not to include them.
Exactly. It's like a backup cleanup, just in case the AI doesn't follow instructions perfectly. Belt and suspenders.
Makes sense. Then parser response looks more complex.
It is. It uses more involved regex to try and segment the entire AI response. It looks for patterns to separate out, say, the AI's thinking process text, the actual code blocks, and any other regular text commentary.
Why separate them?
So you can handle them differently, which leads right into insert a response style.
Ah, presenting it visually.
Precisely. This function takes those parsed segments and puts them in the output display, but with different colors. Maybe yellow for the thinking, white for code, green for regular text. Makes it much easier to quickly see what's what in the AI's output.
Yeah, that would definitely help readability. And for the code itself, highlight code.
Standard syntax highlighting. Again, uses regex to find Python keywords, strings, comments, etc., and applies colors. Essential for making code readable and spotting errors.
A must-have for a coding tool. There's also a simple setrenally function, pretty obvious.
Yeah, it just toggles whether a text area can be edited or not. Useful for displaying the AI's output, or a diff result where you don't want the user accidentally changing it.
Speaking of diffs, generate a diff and insert color diff, showing code changes.
Exactly. Generative diff uses Python's built-in difflib to compare two text blocks, presumably the old code and new code, and creates a standard unified diff.
Like you see on GitHub comparisons.
Yep. Then insert color diff takes that diff output and displays it, usually coloring added lines green and deleted lines red, makes it super clear what the AI changed.
Invaluable for reviewing AI suggestions. Okay, moving into AI request utils. This looks like the engine room for actually talking to the AI models.
It is. It starts with local server available. Simple check is the local server, like LM Studio, actually running before we try to talk to it.
Good idea. Avoids errors. Then do local REST request and do local REST request streaming for generic local APIs.
Seems like example functions, yeah. Showing how to talk to some local REST API.
Yeah.
Crucially, they show two ways. Blocking wait for the whole response. And streaming, get the response back in chunks as it's generated. Streaming usually uses a callback function for each chunk.
More responsive UI with streaming, I guess.
Generally, yeah. Then local request and local request streaming. These look specific to LM Studio's API.
Right.
Tailored for LM Studio. Again, both blocking and streaming versions. And notice they integrate with that stop streaming flag we saw earlier.
Ah, so you can interrupt requests made through these functions too.
Correct. That interrupt mechanism seems built in throughout.
Consistent design. Okay, then dupe-and-reader request and dupe-and-reader request streaming for OpenRitter.
These use the standard OpenIPython library, which can talk to many different APIs, including OpenWriters, again, blocking and streaming options.
And I see some extra headers mentioned, HTTP referer and xtitle.
Yeah, those are sometimes used by services like OpenRouter to track where API calls are coming from. Might be required or just helpful for them. Good practice to include them if the service documentation mentions it.
Gotcha. Follow the API rules. So all these specific request functions, they lead up to the main do reader request function.
This looks like it. Do request acts as the central dispatcher. It checks your settings. Are you using local or OpenRouter? Do you want streaming or blocking? And then calls the appropriate specific function, do local request, dupe-and-reader request streaming, etc.
So it hides the complexity. Smart.
Yeah. Simplifies things for the rest of the code. Just call do request and it figures out the details.
Okay. There's also parse modularizer response. Modularize. Sounds like organizing code.
That's what it suggests. Uses regex again, this time looking for code blocks associated with specific file names in the AI response.
So the AI could suggest breaking code into multiple files?
Potentially, yeah. Like put this class in utils.py and this function in main.py. That's a pretty advanced feature if it works well.
Very interesting. And then the crucial onStop stream function. This is the kill switch trigger.
Exactly. This is the function called, probably by a button press, to actually stop an ongoing request. It sets that global stop streaming flag, which the request functions should be checking. For local streaming, it might also try to close the network connection directly.
The big red button, essential. Okay, quick section. GitHub commit with commit file to GitHub, integration with version control.
Yep, lets you commit the current file directly to a GitHub repo. Needs your repo details, branch, file name, commit message, username, and crucially, a personal access token for authentication.
Streamlines the workflow if you're using GitHub. Nice convenience.
Definitely saves copying and pasting or switching windows.
Now, history pop-up and the history window class, this ties back to Max history logs.
Right. This provides the UI for that history feature. It shows a list timestamp, tab name, maybe a preview of the prompt.
And you can do things with the history.
Yeah. Revise selected sounds key. Lets you pick an old interaction and load it back into a tab, maybe the current one, maybe a new one.
Oh, that's useful. Go back to a previous state.
Exactly. And view full prompt just shows you the complete text of the prompt you used for that history item.
So easy recall and reuse of past work. Good feature. Next, Context Manager pop-up and Context Manager window. Context is huge for AI.
Absolutely. This window seems to let you select other open tabs in the application.
Why?
So their code content can be automatically included as context when you send a prompt from your current tab.
Ah, so the AI knows about related code in your project.
That's the goal. Gives the AI a broader view without you manually pasting everything together. Really helps it generate relevant code.
Yeah, very smart way to handle context.